Hey everyone, welcome back to Crew's class. In today's video, we'll be introduced to the concept of stationary points. Now, this is usually a topic taught with calculus because it's a part of learning differentiation and how to differentiate and different concepts of differentiation. Now, stationary points are the points on a function where the gradient is zero. Now, remember that the gradient is also the differential. So it can also be termed the point on a function where the differential is zero. However, what we need to understand is that any point on a function where we calculate a zero gradient, that point will be a stationary point. And there are different terms for a stationary point. You may hear it being referred to as a critical point. You may also hear it being referred to as a turning point. So that's just supplementary information for you guys to learn. Now, here we have a function f of x, the blue curve. That's the function. Now, it's not drawn to scale. However, it's going to represent our function today. Now, if we have this point right here and this point right here, if we notice this point that I identified as the max point, the maximum point, if we look, we see this dotted red line going through. This dotted red line represents the gradient of this point. Now, remember, when we have a graph, any horizontal straight line on the graph represents a gradient of zero because there is literally no vertical difference. So once it runs from left to right and it's a straight line, that represents that at this specific point we have a gradient of zero. Now, because we have a gradient of zero at this specific point, then therefore this point is a stationary point. And because it peaks upward, this would be known as a maximum point. That would be its classification. Now at this point here, we also have a point of zero gradient, as you can see the tangent. Now, because this is a zero gradient point as well, it is also a stationary point. However, the classification for this stationary point would be called a minimum stationary point because it basically valleys down. As you can see, this kind of peaks up, this kind of valleys down. So these are examples of what a stationary point can be. Maximum point up here, minimum point down here. Now, to work out, or rather to locate a stationary point, if we get a function, we can follow a few steps. Now, to locate and classify a stationary point, first we need to differentiate and equate the function to zero. So we need to find the differential and then equate it to zero, because remember, the differential is the same thing as the gradient. And remember, zero gradient is where a stationary point will be. Second, solve for x and then use that same x value to find the y value. So we're going to solve for x after we differentiate the function. And when we solve that for that x value, we're going to substitute that x value into the original equation so that we can find the corresponding y value. So now that we have third, when we have the x value and the y value, we're going to state the location or the coordinate as xy. This is how we state coordinates. So this would be the location or the coordinate. Now fourth, to classify the points as maximum or minimum, we have to find the second differential. So we're going to differentiate one more time and then we're going to get the second differential. When we do get that second differential, this is represented by the second differential, f of x prime prime, the two apostrophes. The second differential, if it is less than zero, then therefore we have a maximum point. If the second differential, however, is greater than zero, then therefore we would have a minimum point. So, in summary, a stationary point is a point on a function where the gradient is zero. To locate and classify the stationary point, all we have to do is find the differential, solve for x, and then find the y, state the coordinate as xy, and then classify the point as maximum or minimum.